So write down the labelings involved in this one. Alpha, beta, gamma. So can I use this hydrogen? Here hydrogen is there. Break it. Alpha, beta. Migrate this hydrogen. Put double bond it. So we can write like this. Here 1, 2. And alpha carbonyl having alcohol. Okay. So here you write double bond. So break it. Alpha, beta. Beta, gamma, double bond. Alpha, carbonyl, double bond. So this you can also write in one more way. So this is 5-membered ring or not? 1, 2, 3. So here I am writing double bond. 1, 2, 3. 1, 2, 3. Fourth carbon is this one. 1, 2, 3, 4. So here I can write C double bond O pH. Like this they will give an exam. Not like this. So you practice normally like this, but in exam they will give like this only. Now, can I alpha, beta, gamma? Can I use this one? So on this case, don't use this gamma. It is also gamma, but this is not available. Only this gamma is available. So if this is available, break it, alpha, beta. Then write the answer. Alpha, beta if I break. So here I can get a double bond. This is OH and this is pH, and here one more double bond. So this is given in set exam, Maharashtra set exam. Nearly 2 times it is repeated. Photochemical question. NAR is 2. So what is your answer? Can you label this? Alpha, beta, gamma. Then what is your answer? Can I break it? Alpha, beta. So break it alpha, beta. So put double bond between beta, gamma. Then alpha, carbonyl carry double bond. OH and this is pH. You apply the technique. That's what I am saying. If you write with technically easy. Otherwise it is impossible to write the answer. This is given 2 times in Maharashtra set exam. Now this is also important one. Can you give the answer? What is this? Alpha. And what is this? Just wait. You write like this. This is alpha, here beta, and this is gamma. Okay, gamma hydrogen is available? Yes, gamma hydrogen is available, but you won't expect NARISH 2 cleavage. NARISH 2 cleavage is not possible. There is a formation of cyclization product. This is major. This is major. So why NARISH 2 cleavage is not possible? Here cyclobutanol is major but not NARISH 2. See, suppose if I write NARISH 2, what is your answer if it is NARISH 2 cleavage? Can I write like this? Here beta gamma double bond. Then alpha this double bond alcohol, and this is pH. Can I write like this? See what I created here. I am creating a double bond between which carbon? Beta and gamma or not? So this is impossible to prepare, I am saying. Why? According to Brett's rule, you know Brett's rule? According to Brett's rule, creating double bonded bridged carbon is found to be unstable. It is impossible to prepare because at that particular carbon it is non-planar, but we know double bond is a planar. So it becomes a highly strained. So don't create double bonded bridged. Bridged nothing but this one. It is applicable for bicycle and tricycle. See, this carbon don't create double bond. Anywhere don't create double bond here. If you create like this, it is wrong. This is called Brett's rule. You can create double bond over here. You can create double bond like this, but it is impossible to create a double bonded bridged carbon. This is called bridged carbon. Over here, if you create any double bond like this, or over here or here, it is impossible to prepare, first of all, because this carbon is non-planar, but double bond is what? Planar. Planar double bond never survive over here. That is called Brett's rule. According to Brett's rule, it is impossible to prepare because double bonded carbon is planar, but over here it is a non-planar. So we can't prepare double bond here. It is impossible to prepare. So here you write that point. According to Brett's rule, according to Brett's rule, bridged carbon having double bond is unstable. It is found to be unstable. So we can't prepare. So only this is possible, these two are not exist. Norris 2 is not cleavage in this one. So if this molecule is given, major is this. According to Brett's rule, it is not exist. According to Brett's rule, bridged double bond having any sp2 carbon is found to be unstable. So this carbon is always non-planar. This should be always sp3 only. If you create sp2, this is unstable, not possible to prepare. We can write on board, but actually, naturally it is not possible to prepare. That is called Brett's rule. Now here also remains same. Here alpha, beta, gamma. So if I write Norris 2 cleavage, what is your answer? Will you get like this or not? Break bond at alpha, beta and put double bond between them. Can I put double bond here? Normally. If I break bond between alpha and beta, you will get double bond between beta and gamma. And alpha and carbonyl, you will get double bond. Okay? So this is actually the answer. But this won't exist. It is impossible. Why? What is this carbon? Bridged carbon. Don't create double bonded bridged carbon. That won't exist, first of all. So then what is real answer? Real answer is this one. So when Norris 2 cleavage is not possible, then there is a formation of cyclization. This is final answer. Only this is possible. Gamma carbon and carbonyl carbon forms a cyclic ring. So this is exist, but not these two. This is not possible. So this is alpha, beta, gamma, cyclobutanol, because alpha having a bulky substitutions. Ring is present. Adjacent of this ring is present on the time. NORIS 2 is not possible. Cyclobutanol is major. So 1, 2. So gamma carbon and this formation of a ring takes place. Alpha, beta, gamma. Here lighter groups are present. Now NORIS 2 cleavage is possible. So put double bond on outside, you will get this answer. This is alpha carbon. Alpha carbon having a bulky ring. A ring is there or not? So that's why cyclation is possible. Even though one substitution is present, NORIS 2 not possible because bulky ring is present. Now here see alpha, beta, gamma. So when gamma carbon will donate one hydrogen and forms a enol form, you will get 1,4 biradical or not? Initially, when gamma hydrogen donated to carbonyl, you will get 1,4 biradical. Then if any 1,4 biradical having allyl group, then what happens? See, allyl group is get influenced here. So this radical forms double bond. So this is OH and here you will get radical and here you will get one more radical. So later on this radical and this get combined together. That is your final answer. See, when allyl radical formation takes place, this inner radical never combined with this one. Then 1,6 cyclation takes place. So this radical and this radical combine together, and what is your final answer? 6-membered ring. 1, 2, 3, 4, 5, 6. You should write like this. So this carbon having methylene hydroxy, 1 attaches to 6. 6 adjacent double bond is present. That is the answer. So 1, 4. Generally 1, 4 will give cyclobutane. But right now what you will getting? Cyclohexanol. Cyclohexanol is measured only when 1, 4 biradical having one double bond. Conjugate double bond if it is present, you will get cyclohexanol. Here also remains same. See? Alpha, beta, gamma. Gamma hydrogen if you transfer, then what will get? Radical. Here and here you will get radical. Is it 1, 4? 1, 4 break this bond. This radical double bond, this will join here. Same answer. This way. If any 1, 4 biradical having adjacent double bond, the double bond looks like allyl radical, allylic rearrangement will take place. Here also cyclobutanol. Alpha, beta, gamma. So this gamma having, this is a hydrogen. Here 3 hydrogens are there, use one of the hydrogen. Cyclobutanol formation. Alpha carbon having no hydrogen. This alpha carbon having no hydrogen, that's why gamma carbon combined with carbonyl. Cyclobutanol formation. Here also remains same. So this carbon joins with this. See, alpha, beta, gamma. If beta, gamma having any ring, beta carbon, gamma carbon having ring, so on that time cyclobutanol formation will take place. So this will directly connected to OH and pH, and see there is epoxide formation takes place. There is no ring cleavage. If beta carbon, alpha, gamma carbon having any ring, simply this gamma hydrogen transfer to here. Then you will get 1, 4 biradical. These two combined together, you will get 1, 2, 3, 4. 4-membered ring, 4-membered ring with OH and pH. You will not get any ring opening products. Norris 2 not exists. Cleavage is not possible. Because ring carry sp3, if you put double bond here, both are sp2 or not? Not possible. If you create sp2 carbons on ring, it is not survive. Here what is hybridization? sp3. Suppose if I do Norris 2, what is your answer? You will get sp2 or not? You will get double bond. So creating double bond in 3-membered is not exist. That's why you will get cyclobutanol. And here also answer remains same. So you can write this one, next here carbon, carbon, and here it is OH, and this is pH, and 2 methyls. That is the answer. Photochemical, what is the answer? NAR is 2 possible. Photochemical, what is the answer? So this is alpha, alpha having no hydrogen or one hydrogen, alpha, beta, gamma. Alpha having one hydrogen. Okay, bulk substitutions are present. So cyclobutanol formation takes place. So here I can write like this. This is OH and this is pH. This is the answer. This is 1, 2, 3, 4. This one goes here and 2, 3, 4. Is it gamma hydrogen transferred to carbonyl and gamma carbon connected to carbon? Third one donates hydrogen to carbonyl. Third one connected to carbon. So 1, 4 biradical cyclobutanol formation. See this 1, 2, 3, 4 cyclobutanol. Now here we can break this alpha, beta, gamma, break this bond, possible. So if you break this beta, gamma double bond, saturate alpha, here OH and this is AR, that is the answer. Break this bond, put double bond between these two, put double bond between these two, that is the answer. Okay, see. in 1,2 diketones and alpha methoxy ketone. Alpha methoxy ketone, cyclization is preferred. Cyclization is predominant here. Means young cyclization is possible for these two. Don't write NARIS 2 cleavage. So stability of rings are dominating as compared to cleavage products. So 1,2 diketone and alpha methoxy ketone anywhere is given. Don't write NARIS 2 cleavage only, cyclization is possible. So I can write like this C. Here I am writing CH3, CH2, C double bond, C double bond, CH2, CH3. If photochemical is given, this molecule, if 1,2 diketone is given, you can give numbering from any one of the ketone. Suppose see, this is ketone, this is alpha. Otherwise, if you assume that this is a principal functional group, this is alpha. This is functional group alpha, beta, gamma. Transfer gamma hydrogen to carbonyl. Then what you will get? Then you will get a biradical. 1,4 biradical. Join the two. So, here I am writing CH3, CH2. First I am transferring hydrogen. Now already C double bond O is present. Then CH2, CH2, one radical is present. Now this radical join together. Join these two radicals. Then what is your answer? Your answer is cyclic 4-membered ring. So here I can write like this. Carbon having C double bond O and this carbon having alcohol and ethyl. Like this you need to get the answer. So here two carbonyl groups are present. What is hybridization of 2? sp2 sp2. Right now what is hybridization of this carbon? This carbon what is hybridization? sp2. But remaining all are sp3, here sp3 and here also sp3. See here how many sp2s are present? 2 sp2s are there. Now 2 sp2s, after answer how many sp2s? Only 1 sp2. Means strain reduce or not? When strain reduce, cyclization is predominant. That's why this is major. Don't write NARIS 2 cleavage. It is NARIS 2 reaction only, but it is not NARIS 2 cleavage. NARIS cyclization. When 1,2 diketone given anywhere, write down cyclization product. Don't go for NARIS cleavage. And if you assume this is a functional group, this is alpha, this is beta, this is gamma. Suppose if this is a functional group, if you assume this is alpha, beta, gamma, any direction you can take. Clear? Cyclo, this one. This one you are asking. So here double bond and one carbon missing. So here you write double bond. You write one dot, otherwise you write one more time. This double bond and CH2. Alpha, beta, gamma. If you count like this, alpha, beta, gamma, ring carbon it is. So if you take down as alpha, beta, gamma, but see this gamma is not very close to carbonyl. This gamma is very close to carbonyl because if you take any 3-membered ring, this is CS3. Then what about next one? This is C double bond O, AR. So on that time if you assume as alpha, beta, gamma, this gamma is very close here. But if you take alpha, beta, gamma, so this gamma hydrogen below and carbonyl is above. This gamma carbon, suppose if you give numbering as alpha, beta, gamma, that is possible. But I am not giving like that because here hydrogen is below, carbonyl is above over here. Now this is available, this should be taken as gamma. Clear? In both cases we can break ring. We can reduce 3-membered ring size. And answer remains same. If you take any direction, answer remains same. This is not major. Here you will get tautomerism. If you go for tautomerism, you will get same answer one more time. Using this hydrogen, your answer remains same. but clearly use this hydrogen because it is very close to this arrangement. See, this is above and here also given above. Above means this is cis. Suppose above below I given, that is trans, still your answer is same. Clear? Right. Always conjugate products are predominant. This should be taken as alpha, beta, gamma, alpha, beta, gamma. So here OH, CH3, CH2O, and this will be the answer. Alpha methoxy ketone. See, this is alpha methoxy, here alpha ethoxy. You can take not only methoxy, even you can take alkoxy. Any alkoxy, your answer remains same. Cyclobutanol. You need to join these two. Join these two, convert this into alcohol. Join these two, convert this into alcohol. Gamma hydrogen transfer followed by alcohol formation. Cyclobutanol, oxetane. So that is end of Norris 2. So this should be taken as reference. This is alpha, beta, gamma. How to write answer? Write down 4-member ring. So this is double bond. And here there is a connectivity of hydroxy and here this group. So this carbon carry isopropyl. Now here see, if you take this as a reference, this is alpha, beta, gamma. Gamma connected to carbonyl. When gamma connected to carbonyl, you will observe like this. This C double bond is, this gamma connects here and you will get alcohol. Every time 4-membered. When 2 ketones are given, convert into 1 ketone. Molecule is stable. And here 1 sp2 and here no sp2. Oxygen is more stable. In pattern of Buch reaction already we discussed, oxygen is major, that's why we are preparing oxygen in this pattern. So these are exception reactions, you need to remember. So don't go for Norris cleavage, go for Norris cyclation. So that is end of Norris 1 and Norris 2. So nourish 1 and 2, pattern of Buch reaction, 4 reductions are over. Next is photochemistry of alpha comma beta unsaturated carbonyls. Major part is over. Photochemistry of alpha comma beta, only rings we can apply photochemical reaction, that we are going to discuss in your next class. Photocyclodimerization, photocycloaddition, cysteines isomerism, okay, then double bond migration, then photochemistry of 4,4, cyclohexene, hexadiene, dinone phenol rearrangement. The dinone phenol rearrangement also comes in this pattern. So up to now we learn only photochemistry of only carbonyl group. Only carbonyl we are learning up to now. But from now onwards we are going to discuss what is the photochemistry of alpha comma beta. This is carbonyl. It is alpha, it is beta. Alpha comma beta unsaturated carbonyl. Only ring. We are not going to discuss open chain. Okay, photochemistry of alpha comma beta. So these reactions are most important. 4,4 dialkyl cyclohexenone. Photochemistry of cyclohexenone. This will come tomorrow. Okay. So nourish 1, nourish 2, pattern of Buch reaction, photo reduction. From this, one question is compulsory. From this 4. As compared to photo reduction, PB, N1, N2. These 3 are most important. Clear? Lumi ketone next will come over here. Then photochemistry of benzene, photochemistry of olefin, oxidipymethane rearrangement, dipymethane rearrangement, then photooxidation. Then photochemistry of benzene, a simple concept is there. So we will discuss in your next class. You revise up to here, it is most important part. If you know this one, then applications are very easy for upcoming topics. You need to make a differentiation. What is difference between normal carbonyls and conjugate carbonyl? What is normal carbonyl? This is a ring carbonyl. Is there any conjugation to this one? No. Now we are going to discuss a carbonyl which is conjugate to double bond. This is called alpha comma beta unsaturated carbonyl. Head to head attachment, head to tail attachment, polar, non-polar solvent, which is major, which is minor, everything will be discussed in your next class. Okay. So we'll stop here, we'll continue in your next class. So evening schedule will be announced in your WhatsApp group, and tomorrow morning as it is 10:30 to 1 you have a organic class. Okay, we'll stop here.